All right, thanks for joining today. My name's Jeff Demuth. I'm a solutions architect at AWS on our geospatial team based out of Austin, Texas. In this video today, we're going to install ArcGIS on Kubernetes using the Amazon Elastic Kubernetes Service, or EKS. So to get started, this session is going to be all through the Cloud Shell again, so I've got the entire configuration scripted out. I'll also provide the script and a link that has all of these commands. In the description of the video. So the first thing we're going to do is we're going to install the kube control command. This is a binary that essentially interfaces with Kubernetes. It's the same binary whether it's Kubernetes running anywhere. It's really how you run commands against the cluster. This will give us the version that we installed. The next thing we're going to install is our custom Kubernetes infrastructure setup binary. It's called EKS control. And this allows us to easily create a Kubernetes cluster. Next, I'm going to pull down a simple Git repo that's got our cluster configuration settings in it, and I'll go through those files as well. So the cluster.yaml file here defines our environment. So I'm going to deploy this just on one large node for demonstration purposes. Normally you'd had two nodes split across multiple availability zones, but when we deploy this, we're going to choose the development deployment option. And so since it's a development environment, it's fine to just use one large node. And then there's a couple other files in here for setting persistent storage, configuring the storage manifest. I've also just downloaded a key file. So you can see there's a key file in here now as well. And that will automatically get generated if you run the Kubernetes deployment script. But because I've run it in the past and it helps with the automation, I've already generated it and saved it, and I'm re-downloading it. So I also just downloaded, through my Esri, you'll have access to this ArcGIS Enterprise deployment, a tar file. And this is going to be for 11.1. And really what you're looking for is that deploy.shell file. I've already scripted out the parameters for it, but that's pretty easy to walk through it. It just asks you, do you want a load balancer, upload your SSL certificate, things like that. And then it generates a deployment file. And then I've also downloaded my ArcGIS Kubernetes license. So as part of some of those variables that we're going to need for the deployment script and just for setting up Kubernetes in general, we'll start grabbing those. I'm going to grab my VPC. This is just listing out all the VPCs and grabbing the first one because I only have one. I also run this command to just store it in a variables file. With Cloud Shell, if it times out, it'll reset your environment variables, and it's an easy way to reset those when I have all the parameters in a variables file. Next, we'll grab 2 subnets. I'm going to grab my VPC default security group. For a production environment, you'd want to create a separate security group, but for demonstration purposes, it's easier to just use the default. So now I'm going to update that cluster YAML file that we downloaded. There was a section that was commented out where it would let you define the subnets. I'm going to swap the subnet IDs that I've just grabbed with those subnets. And then same thing for a couple of these other variables. So in that cluster, I'm just going to uncomment VPC, private subnet, and the subnet ID parameters. And then that's basically it for creating the cluster. So now we run using the EKS control binary, create cluster. We pass in that cluster YAML file. This will take about 10 minutes for that cluster to come online. There we go. And our cluster is up and running. I just realized this is probably a little small on the font. Let's see if it'll let me increase it. Yeah. There we go. That should be better. All right, so now we have to set up OIDC. And I'm not super familiar with what all the OIDC is doing, but from my understanding, it's like it's allowing the Kubernetes cluster to assume like an IAM role and interact with other AWS services. And then we're going to create some IAM policies. And I'm going to insert our account number and some other variables into that. This all has to do with kind of that OIDC connection and allowing Kubernetes to use it. And part of that is for the persistent storage. So ArcGIS requires persistent storage for Kubernetes, and Kubernetes needs to be able to spin up a persistent EBS volume or EFS share for its persistent storage. In this example, we're going to do a EBS volume. There's also a module that gets added to the Kubernetes cluster that makes the Kubernetes cluster aware of how to interact with EBS. And then we're going to bounce those to pods inside of Kubernetes. Then there's a manifest file. This is also one of the files that was downloaded from Git. That's just what sets up the persistent storage. This command is going to go out and grab the public IP or DNS name of our EC2 instance that was spun up for Kubernetes. Now there's another command I set. I set an environment variable that's got the essentially the registry password for downloading the ArcGIS containers. Now, once your account has been approved by Esri, they'll add it to their private repository where they store their containers, and that's how you connect it, pull the containers down. So the next thing I'm going to do is I'm going to spin up a load balancer. I'm going to create an external one. As of, I think, 11.2, you have the capability to create AWS ALB load balancer inside of the Kubernetes cluster. That's more the recommended best practice way to do it, especially when you start managing multiple Kubernetes environments at scale. But again, for the sake of demo, we can just use an external ALB load balancer, and there's nothing wrong with that. It works perfectly fine. It's really the main concern is a scale problem. Is if you start having hundreds of ALB load balancers, you're going to want that managed by Kubernetes. It's a little easier to manage at its scale when everything's inside the Kubernetes system. Okay, and I gave that command a minute or two to run. I don't think it's needed. I think you can run these right after it, but just to be safe. And I'm just going to grab the ARN of the ALB and its DNS name. Because I'm going to use those, well, mostly the DNS name, to create a self-signed SSL certificate, which we're going to use on the ALB. So just an open SSL command. We pass in ALB DNS name, create a PEM file, and then package it up into a PFX file. Now we're going to take that certificate and upload it to AWS Certificate Manager. And I'm just going to copy the ARN. Next, we're going to create a Kubernetes target group, or just a regular target group on the ALB. That's going to check the ArcGIS index.html as its health check. I think there's actually some better health check URLs, like server and portal. Previously they had specific health check URLs, but we can use this one for now. I'll have to look up which one, what the new health check URL is for Kubernetes. And this was a port number that was specified in our deployment. You can pick the port number when you run that deployment script, or you can let it dynamically assign one. I have it hard set just so it's consistent. Next, we're going to create a default listener on the load balancer. That's just going to take everything destined to 443. It's going to use that certificate we generated, and it's going to forward it to our target group. This is the command that swaps out that registry password and our DNS inside our app.properties deployment script. And then I originally, that Git package built it with an older version. I'm going to comment that out, make sure we've got the latest one. And then this is the deploy.shell. I'm going to pass in that app.properties file. If you run this command without this, it's just going to ask you those questions. So do you want to create a load balancer? What's your SSL cert? And this runs pretty quick too, maybe 7-8 minutes. I should add, while this is running, this is kind of the original way that you would deploy the Kubernetes. They've got some new deployment options, which I haven't had a chance to look into yet, but maybe I'll do a follow-up video where you can deploy using a Helm chart. That's a pretty popular deployment method for Kubernetes, is to use Helm charts. And it looks like our environment is up. We'll go ahead and copy this URL. And I need to run a couple commands here to register our instance with the ALB. Okay, so I noticed that I had to open up 2 security groups, which I've got a script for normally. But basically this default security group that I've got on the load balancer, I opened up 443. And then my EKS manage node should have been also in the default security group. I probably just missed specifying it in the YAML cluster YAML file, but it created a new security group. So I had to open up that 30559 firewall rule there so that the load balancer could talk to it. And we can see on that target group, we've got our EC2 instance registered, it's healthy. In the EC2 console, we can see the Kubernetes instance. Where'd it go? It's running, and this is a managed node. There's 2 node options you can deploy for EKS. One is kind of self-managed, where you're responsible for patching the EC2 instance and the security of it, but it allows you to customize the Kubernetes nodes more. With the managed node, it's a Amazon image. Amazon's responsible for patching and maintenance of that Kubernetes node, and it makes the management of Kubernetes easier. But now we can grab our URL. This is the name of our ALB, ArcGIS Manager. Because we used a self-signed certificate, that takes us here. We'll say OK, accept. And then it's easy to fix that self-signed certificate error as well. So because that certificate's on the ALB load balancer, you can swap that out with a public certificate once you get assigned one. But Kubernetes is then going to walk us through the setup. Here's where I mentioned we're going to choose development. And I'll upload my license file. And we'll fill out the information. And then here we'll just click. Actually, we have to put our, in that storage manifest file, you have a storage class name. It's just called, I just named it ArcGIS, so that's the only thing we have to enter in here. And finish. And so this is, so initially when you run that deployment, it kind of sets up the base number of containers you need to run your configure site. Now it's going to actually go in and it's going to validate the license, and then it's going to start spinning up all these other containers. So there's a separate container for portal, services, the relational store, object store, and that's what allows those services to all scale out independently. So they're all separate pods with containers in them that are scaling independently. This step will take about probably another 10 minutes to run. There we go. So when it finishes, it just redirects to this page. We've got our link to manager. We've got our link to home. Let's go ahead and log in. And this will look pretty familiar. But what won't look familiar is manager. So with manager now you can see the different pods that have been launched and the status of those pods. But other than that, it is actually pretty similar other than the pod information. One of the other big benefits of EKS is with those managed nodes, I've got a lot of monitoring also built into them. So we can go into the Kubernetes service. We can see our cluster. And then the EKS service actually also has pod level visibility. So it can see what pods are running. You can see your nodes. We can click on a pod and see events. And so you just get a lot of great visibility both from ArcGIS Manager but also from the Elastic Kubernetes service into what's going on inside of the Kubernetes cluster. And so with that, that's all I had for this video. If you like this, go ahead and like and subscribe. Probably do another variation of this. Maybe we'll show like how to upgrade. One of the big benefits of using Kubernetes is these containers have become stateless, and so when you upgrade, what Kubernetes will do is it'll spin up a new set of containers, repoint DNS to the new containers, and shut off the old containers, so the upgrade process is much smoother, as well as you get capabilities when you publish services to do, deploying different versions of those. Like, I don't know if it's quite A/B testing or blue-green testing, but you get those types of capabilities. But yep, again, that's all I had for today, and thanks for joining.